Hello, welcome back to my channel Study With Me. Today I'm going to explain about Chemistry Higher Level Paper 1, May 2023, Time Zone 1. If you find this is helpful, don't forget to subscribe to my channel and let's get started. Okay, question number 1. Which information does the molecular formula provide? Molecular formula is used to describe the actual number of atoms present in molecule. For example, C6H12O6 is the molecular formula of a glucose, and the empirical formula represents simple ratio of atoms present in molecule. So empirical formula is simpler than this, which is CH2O. Therefore, the answer is the actual numbers of atoms in molecule. A student heated a known mass of zinc powder in an open crucible until there was no further mass change and recorded the final mass. What would the student be able to derive from this data? So, a mass of zinc is unknown. So, what the students can derive from this data? Percentage composition of zinc oxide, empirical formula of zinc oxide, and molecular formula of zinc oxide. Knowing the mass of a substance allows you to determine its percentage composition by calculating the proportion of each element's mass within the total mass of the compound. So therefore, percentage composition of zinc oxide can be derived. When the mass is known, one can calculate the number of moles of each element present using the molar mass of each element. Then find the smallest whole number ratio of this molecule. Therefore, empirical formula of zinc oxide also can be derived. However, additional information like the compound structure, it's not possible to determine the molecular formula precisely only by knowing the mass of zinc powder. Therefore, molecular formula of zinc oxide cannot be derived. The answer will be A. What is the molar mass of a gas according to the following experimental data? So the equation is given here, PV equal to nRT. So asking for molar mass, so we need to derive this formula, M divided by MR. Okay, and then we rewrite the formula. So to find MR, it will be M times R times T divided by PV. And here is centimeter cube, so we convert it to decimeter cube. So therefore, the mass N times R times T divided by pressure and volume. What is the maximum number of electrons in energy level N equal to 4? Number of electrons for N equal to 1 is 2. So let me write it down here. If it's N1, maximum electron will be 2. If it's N2, maximum electron will be 8. If it's N3, maximum electron will be 18. If it's N4, maximum electron will be 32. Which statement best explains the first ionization energy of sulfur being lower than that of phosphorus? So let's see the electron configuration of phosphorus. The shorthand is 3s2 and 3p3. And for sulfur, it will be 3p4. So if we write it down to the orbital, it will be ampere, and this one, it has 1 pair. Therefore, the fourth electrons from the sulfur will experience a repulsive force from the third electron makes it easier to remove. So we need less ionization energy compared to for sulfur compared to phosphorus. That's why the answer will be B. Okay, what can be deduced from the period number of an element? Highest occupied energy level, number of sublevels in the outer shell, or number of outer electrons. Okay, so I'm going to take an example, period 2, where the elements will be Li, Be, then B, C, N, O, F, and E. So the electron configuration will be 2s1, 2s2, 2p1, 2p2, 2p3, 2p4, 2p5, and 2p6. So from this, we can actually see highest occupied energy level and number of sublevels for these elements. Therefore, the first and second are correct, but for number of outer electrons cannot be seen because this should be down a group. So when you go down a group, the number of outer electrons are not increased. For example, group 1, so all elements in the group 1 will have one valence electron. So it shows that one electron on the outermost shell. Therefore, number of outer electrons cannot be seen or deduced from the period number. That's why the answer will be A. In the following unbalanced equation, X represents an element which oxide reacts with water are shown. So it's a element X that produce alkaline, therefore it should be a metal. So either Na or Mg. So let's derive or make it an ion for Na2O and MgO. So for Na2O, if we breaking it down, so Na plus will be O2 minus. If it's react with H2O, so it will be H plus and OH minus. So Na with OH, it will be NaOH. So this is not the answer. And for MgO, if we making it into an ion, okay, so it will react with water, OH minus and H plus. So Mg will combine with Mg will combine with OH because positive ion and negative ion. So Mg2 plus and OH minus crisscross method. So it will be Mg OH2. So the answer is B. Which element is not a transition metal? It's Zn, because Zn doesn't form colored compound, and also it has the full D subshell. If we check the electron configuration of Zn, it will be 4s2 and 3d10, so it's full D subshell. Which substance is likely to have an ionic lattice structure at 298 K and 100 kilopascal? Okay, as a lattice structure has high melting point due to strong electrostatic forces between oppositely charged ion in the lattice, so it requires significant energy to break the bonds. And lattice structure, when it is in the liquid state, will be able to conduct electricity because it has a free moving ions. Therefore, the answer is D. Why does the melting point of the element decreases down group 1? As you go down a group, number of electron increases because number of electrons increases. So number of electron increases, number of shells also increases, radius of metal will increase. Consequently, the metallic bonding between atoms become weaker as the outermost electron are less tightly held by the nucleus because the radius increases. In which molecule does the central atom have an incomplete octet of electrons? It's BF3, because if we calculate only 1, 2, 3, 4, 5, 6 electrons, so it doesn't have incomplete octet of electrons. Let's see, what about H2SE? So 1, 2, 3, 4, 5, 6, 7, 8. And pH3. 1, 2, 3, 4, 5, 6, 7, 8. And for OF2, 1, 2, 3, 4, 5, 6, 7, 8. So that's why the answer is BF3. What are the formal charges on the atoms in this molecular ion? So for formal charge, the equation will be number of valence electron minus half of number of bonding electron minus number of non-bonding electron. So let's calculate for S. S valence electron, it's 6 minus half. Non-bonding electron, we have 4. Sorry, bonding electron, we have 4 as well. 1, 2, 3, 4. And non-bonding electron, also 4. For C, valence electron, it's 4 because it's a group 4. So bonding electron, we have 1, 2, 3, 4, 5, 6, 7, 8. And there is no non-bonding electron. Therefore, it will be 0. And for N, it's 5 minus bonding electrons are 4 and non-bonding electrons are 4. So it will be -1. The answer is B. Which types of hybridization are present in glycine? So asking for this C, O, and N. Okay, for C, let's breaking it down so it will be a lot clear. So this will be sp2, and for N, it has lone pair here, so it will be sp3. So for O, C double bond O, that would be sp2. So the answer will be A. What is the enthalpy change for the following reaction? So we see that CH4 is on the left side, but CH4 here is on the right side. So we need to flip this reaction. And H2O is on the left side, and H2O here is on the right side, but the coefficient is 2. Here is 1. It means we need to flip it, and we also need to divide it by 2. And for CO here is on the right side, but the coefficient here is 1, but here is 2. It means we need to divide this by 2. So let's write it down back, this reaction. So C, because it's divided by 2, so it will be C and half O2 and CO. This we need to flip it. So CH4 will be right here and producing C plus 2H2. And this we need to flip it and divide it by 2. So it will be H2O produce H2 and half O2. So we need to eliminate this, and we need to eliminate CO. We don't eliminate because we need it, and then C, we need to eliminate it, and then CH4, we need it because it's available here, and then H2O, we need it, and CO, we need it, and H2, we need 3. So this will be negative 111. This will be plus 74, and this will be plus 242. So the answer will be B. Which allotrope, oxygen or ozone, has the stronger bond between O atoms and which absorbs higher frequency UV radiation in the atmosphere? For ozone, that would be like this, the lowest structure. And for oxygen will be like this. Okay, so for ozone, it will experience delocalized structure, therefore is not very stable, so the energy will be low and the frequency also will be low. Not the same like ozone, because ozone here is only double bond, so it has high energy and high frequency because energy is directly proportional with frequency. And at the same time, ozone, it has only double bond. Sorry, oxygen, it has only double bond, but for ozone, it has double bond and single bond. Therefore, it has short double bond, short bond for O, for double bond, and then long for bond O. So that's why the answer will be C. Which diagram shows the enthalpy changes for dissolving a solid Mx in water if the process increases the temperature of the solution? Ionic bonding broken, or lattice enthalpies, to form ion dipole attractions between the weaker molecules and individual ions, or hydrogen enthalpies. So which diagram shows the enthalpy changes for dissolving a solid, which the process increases the temperature of the solution? So the enthalpy of solution is when 1 mole of gaseous ion is surrounded by water molecules to form an infinitely dilute solution, and is always exothermic. So we need to find the enthalpy of solution that is exothermic, which is this one. And for the lattice enthalpies is when 1 mole of ionic compound is broken apart into its constituent gaseous ion, and most of the case is always endothermic, and this one will be endothermic. So the answer is D. What is the correct combination of delta H and delta S for reaction, which is only spontaneous at high temperature? Okay, so the combination of delta H and delta S that indicates spontaneity at high temperature should be bigger than 0. So if delta, let me write down here. So if delta H bigger than 0, therefore the reaction is endothermic. So the reaction will be proceed, and the delta entropy, so delta S, if it's bigger than 0, they will experience increase in entropy, higher kinetic energy. So if we plot it into the formula, delta G is delta H T delta S. Okay, let me write out here. Okay, if delta H bigger than 0, delta S also bigger than 0, so the reaction that will be spontaneous, delta G, should be negative. So if delta G is negative, so if we write back down the equation, will be delta H smaller than T delta S. I missed one formula, so let me write down like this, smaller than 0 because should be negative. So if we write it down back here, so it will be like this, and if we divide it by delta S, it will be smaller than T. This shows that the ratio of delta H to delta S must be less than the temperature for the reaction to be spontaneous at high temperature. What happens to the average kinetic energy of the particles in the gas when the absolute temperature is double? So the absolute temperature is double. The average kinetic energy of the particle in gas is directly proportional to the absolute temperature. There is one formula, it's Boltzmann's constant. It's involving Boltzmann's constant, which is 3 kT. So K is Boltzmann's constant. You can see that the kinetic energy of the particles is directly proportional to the absolute temperature. Therefore, when the absolute temperature is double, the average kinetic energy of the gas will be also double. Okay, so which calculation determined the initial rate of this reaction? So I'm not really sure if I can show it to you right here. So yeah, I mean, if you have the paper with you, so this will be the initial rate, so you can get the answer. The initial rate for this will be 0.40 minus 0.20 divided by 10 minus 0. All right, so you just need to draw the tangent line and you will get this D as the answer. What is the order of reaction with respect to A given the following reaction mechanisms? So we need to pay attention for the slow, which is rate determining step. Okay, so we can see the rate here will be K, A, and B. Their respective order will be 1. So in total will be 2. Number 21, which pair of graphs indicate the same order of reaction? If it's rate and concentration of reactant, like this graph, this is second order, and this one will be first order, and this 0 order, and this will be first order. Be careful with the labeling of y-axis and x-axis. Okay, and this one will be 0 if it's concentration of reactant versus rate. And for this one will be first order, and will be first order as well. So the answer will be D. We just need to be careful when you see the labeling for the x-axis and then y-axis, okay, because they are different, they're not the same. Okay, for number 22, this reaction has an equilibrium constant Kc 650. These are the reaction. And what will happen if we halve the coefficient? Okay, this is something that I'm not really sure, because for the IB mark scheme, the answer is C, 1 over square root of 650, while if reverse reaction, Kc will be Kc to the power negative 1, and for half of the coefficient, it will be square root, and for the double, the coefficient, it's square. Okay, so I try to plot into the number by giving the example. This is the example. So let's compare if we have the equation coefficient. Okay, so this half of the coefficient with the same concentration. So Kc will be 3 to the power 2. Okay, 3 to the power 2 because coefficient is 2, and 0.3 times 0.3 because coefficient is 1 for both. So you will get 100. And if I do for the half of coefficient, so 3, and then coefficient is 1 here, so 0.3 and 0.3 to the power half, so you will get 10. So Kc2, let's give this as a Kc1, and then this one is Kc2. So Kc2 is square root of Kc1 because it's 100, and this one is 10. But the answer is C. All right, based on the IB Mars scheme. So I go to the next question. Which equilibrium constant corresponds to the spontaneous reaction with the most negative value of delta G? So the equation is delta G minus RT ln K. If Kc smaller than 1, then K will be negative and delta G will be positive. So it's non-spontaneous. But if Kc bigger than 1, then K is positive, delta G will be negative. So this will be spontaneous. So Kc should be bigger than 1. And the biggest number for Kc is D. Which products are formed from the neutralization of nitric acid and calcium hydroxide? Okay, so let's make the reaction here. I always teach the student, if we want to make a reaction, the easiest one, make it them into ion if you're not really master it. So Ca2 plus, because these two belong to Ca, and OH minus. So you combine negative ion with positive ion, so it will be Ca2 plus NO3 minus. So you use crisscross, it will be CaNO3. So calcium nitrate, so H and OH, it will be H2O. So the product will be, let me just complete this. Okay, so the product will be calcium nitrate and water. Which combination describes a strong Bronsted-Lowry acid? Bronsted-Lowry, it's all about proton, which is H plus. So for acid is proton donor, and then for base is proton acceptor. Okay, so if we make the equation CH3COOH plus H2O will produce CH3COO minus and H3O plus. So this acid and this conjugate base. So CH3COOH and CH3COO minus is actually a conjugate acid base pair. Conjugate base here is conjugate base, is considered weak as it less likely to readily accept proton in solution. Therefore, the answer will be B. What is the relationship between acid and base dissociation constants in a conjugate acid base pair? So Ka and times Kb will produce the water constant. So that's why the answer is A. Number 27. So what is the pH at the equivalence point in this titration? So if we see in the middle, this will be the equivalence point, which is 5. Which change involves oxidation of N? So let's breaking it down. If it's in H3 2N2, so this is a free element 0, this one plus 3 and negative 3. If it's NO2 2NO, oxygen negative 2, N is plus 2, NO2, so negative 4 and plus 4. For N2 2ALN, this negative 3 and plus 3. So I will go down actually. I will actually start from Al because it's group 3, so plus 3, negative 3, and this one is 0. And NO2 2 and 2O4, so negative 4 plus 4, and O4 is negative 8, so plus 8. This will be plus 4 because for N2 is plus 8, for N only is plus 4. Therefore, the answer will be A. Which combination describes an electrolytic cell? So energy change in the electrolytic cells, it's electrical to chemical because it needs energy. And it's also non-spontaneous because it requires an input of energy. So the answer will be C. What is the standard potential difference of this cell? So this one will be oxidation and this one will be reduction. So the formula for E cell will be reduction minus oxidation. So this will be positive 80 minus negative 45. So the answer will be B. Which statement is correct about the ions in a cell assembled from this half cell? So the more negative, it's oxidation. Okay, I have this panic. So positive is anode, and then negative is cathode. So another one is anode is anox and cath red. So anode will experience oxidation, and then cathode will experience reduction. Okay, so oxidation will be positive electrode. So zinc is more negative in terms of E cell. Thus, the negative ion will flow to Zn as it is at positive electrode. That's why the answer will be A. Which formula represent an ether? Ether name is alkoxyalkane. So for the functional group, it's COC. So COC. Why does benzene undergo substitution more readily than addition? In benzene, the pi electrons are delocalized and make structure more stable. This delocalization distributes electron density throughout the ring, making the carbon-carbon bonds more stable, so it's very difficult to break. So the answer will be C. Delocalized electron cause resonance. So if there is resonance and then the pi electrons, the delocalized electrons, and this all stuff making the carbon-carbon bonds are stable, so it's difficult to break. What is the product of the reaction of butene with bromine? So if we draw the Lewis structure, if we draw the structure of this plus Br2, so this will break CH3, CH, CH, and then this will be Br, and CH3. So 1, 2, 3, 4, it doesn't matter if you start also 1, 2, 3, 4 because it's butene, so it's symmetrical. So it will be 2.3 dibromobutane. Which molecule is optically active? If it's optically active, it's based on this symmetry and chirality. A chiral center is a carbon atom bonded to 4 different substituents. So let me try to breaking it down. For A is CH3, CCl, Cl, and CH3. For B, it will be CHCl, Cl, sorry, it's H, it's CCl and HCH3. And for C, and for D, okay, 2.2 dichloro, 2.2, okay, dichloro, 1.2 dichloro, 1.3 dichloro, 1, 2, 3 trichloropropane. So you can see here, okay, this C is a chiral center, okay? So that's why the answer is B. Okay, which pairs of reactants could produce the following intermediate? Producing carbocation intermediate proceed in two steps, which is SN1. SN1 mechanism is a tertiary halogenoalkane. So we need tertiary halogenoalkane. This one is tertiary halogenoalkane. Okay, so C, 3C, so it's tertiary. But for this one is primary, so therefore this one is not. But what about this? The double bond acts as a nucleophile. So this double bond will attack HCl, forming a carbocation intermediate first due to the loss of hydrogen. So the answer will be A. Which terms describe the nitrium ion in the nitration of benzene? NO2 is an electrophile. Electrophile forms a new bond by accepting a pair of electrons from benzenes, pi electron cloud. And electrophile, because it accepts pair of electron, so it's a Lewis acid. What is the percentage error if the enthalpy of combustion of substance is determined experimentally to be negative 2100 kilojoule per mole, but the literature value is negative 3500 kilojoule per mole. So for the percentage error is the experimental value, it's absolute, and then accepted value divided by accepted value. So if we plot, it will be 2100 minus 3500 divided by 3500 times 100 would be 40%. Okay, number 39. If we draw this structure, this for A is CH3COOCH3, and for B is CH3C double bond O and CH3. Okay, so if it's two and we check on data booklet, okay, so we mostly stuck on this. Okay, so ester or ketone. So ester is 2 to 2.5 and ketone is 2.2 to 2.7. All right, so we stuck on this 2 more because the peak is around 2. Okay, here is the B 2.2 to 2.7 and this one 2.0 to 2.5. Okay, the decision to identify the compound as a ketone rather than an ester, despite the chemical shift overlapping with both functional groups, because we don't have any other data, only this one peak. Therefore, it could be attributed to the broader chemical shift range that typically associate with ketone because it's broader. So that's why the answer here is ketone. Okay, what is the index of hydrogen deficiency? Okay, what is the index of hydrogen deficiency of adenine? Okay, the formula will be 2C plus 2 minus H minus X as a halogen plus N. We don't have halogen. So divided by 2 is 2.5 plus 2 minus 5 plus 5 divided by 2. So 2.5, so 2, we don't need to have 2C anymore. So 2 times C what is the index of hydrogen deficiency of adenine? So the formula will be IHD 2C plus 2 minus H minus X as a halogen. We don't have this halogen plus N divided by 2. Okay, so that would be 2 times 5 plus 2 minus 5 plus N, which is 5, divided by 2, and you will get 6. Alright, that's all for the May 2023 Time Zone 1 Paper 1 HL. If you find this explanation is helpful, don't forget to subscribe to my channel, and I will do other past papers as well. And thank you for watching. Bye for now.